as well.
Okay, so hello again, everybody. I am here with a skewish bow tie. No one's told me. Please put some buttons again. So Nish is here. Mike is here. How are we doing, Mike?
Yeah, I'm all good.
What's the session?
We're going to be looking at a bit of physics today, because I think I left you on Tuesday. Yeah. So we're going to look at some physics, and we're actually looking at nuclear radiation today.
Nice. We got the proper PPE for this session. Is that what we need?
It all ties in. There's a method. There's a method behind my madness.
Nice. Mike, I won't waste any more of your time, sir. I'm going to share your screen with everybody now.
Nice one.
And then you are good to go, sir.
Nice one. Okay, so everybody, we're going to be continuing with physics. You may have noticed that I've been chopping and changing between physics, and we're going to kind of build on a new topic, because I left you last time where we were looking at an earthing and how to be safe regarding electricity. The topic that follows on from electricity is nuclear radiation. And we're going to take a look at exactly what it means to be radioactive and what different types of radiation there are. So, we're going to use a bit of chemistry knowledge here. And what you guys should know is that substances are made up from atoms, and every single atom has, it has two main parts. It has this central part in the middle, which we refer to as the nucleus. And we also have these energy levels, or sometimes they're called shells. Now, if the atom is not radioactive, then, the nucleus is stable. But sometimes that nucleus could be unstable. And I'll just quickly sketch that for you here. Sometimes the nucleus of an atom may be unstable. And it can be unstable due to having too many neutrons in the nucleus. But the important thing to realize here is that any time that we have an atom and that atom has an unstable nucleus, we would refer to this as being a radioactive atom. And I'm sure many of you you've seen the symbol for radioactive materials. If you've watched The Simpsons, you know that Homer Simpson works in a nuclear power plant, and you may have seen the symbol that looks like this. I think there's a game, not too sure. There's a game where this is a symbol as well, but it basically means it's radioactive. Now, radioactive atoms are unstable, and they want to become stable. These unstable nuclei, these radioactive atoms, they don't want to be unstable. They actually want to become stable. Now, the way that these radioactive atoms can become stable is by releasing radiation. And, you know, when radiation is released, you know, the nucleus becomes a lot more stable. It's important to realize, guys, as well, that this process of releasing radiation, it's a very random process, i.e., you can't predict when the atom will release radiation. And there's a key word that you would be expected to use when talking about the release of radiation. And that key word is decay. Okay? So if I was to use that word in a sentence, I would say that radioactive atoms have an unstable nucleus. To become stable, they release radiation, and this is called decay. Now remember that this process is random. And there are 3 different types of radiation. There are 3 types of nuclear radiation. And you would be expected to know the properties of these different types of radiation. There are a few properties that you would be expected to know of them. So I'm going to draw just a quick kind of like summary table at the bottom here. And what we're going to do is we're going to summarize some of the key properties of nuclear radiation. That's what we're going to do. So let me put mine across here. So as I've said, and I'll do them in different colors so that they stand out. Let's look at first of all, the type of radiation. Okay, the first type that we're going to look at is something called alpha radiation. Alpha radiation has the symbol, it looks like a fish, but we give this the symbol for alpha radiation. Now, what you typically need to know is what the radiation, what it's made of, okay? So you should know what alpha radiation is made of. You should know the range in air. In other words, how far this radiation can travel. You should know what it's stopped by. And you should also know the ionizing strength. And I'll get onto what some of these terms mean in just a second. So as I've said, let's focus on alpha first, and then we can look at the other 2 types of radiation. So alpha radiation is made of 2 protons, and it's also made of 2 neutrons. Okay? And because it's made up of 2 protons and 2 neutrons, the actual charge of an alpha particle or alpha radiation, it has a +2 charge. Now, you may remember from, I think it was my first chemistry video that I did online, I spoke about the charges of these subatomic particles. And remember that we said protons are +1, they're positively charged, and neutrons are neutral, they have a 0 charge. So an alpha particle or alpha radiation would have a charge of +2. Now, alpha radiation, its range in the air, in other words, how far it can travel. Well, alpha radiation can only travel up to about 5 centimeters. It can't travel any further than 5 centimeters. It just starts to break apart. So the alpha radiation has a range of about 5 centimeters. Now, interestingly, alpha is typically stopped by paper, or it can be stopped by skin. So it doesn't penetrate very far. Alpha doesn't, because it's stopped by paper or skin. Now, this last column here, the ionizing strength, it typically causes a lot of problems for people. But when we talk about ionizing, it basically means the ability to knock off electrons. Now, to the average person, this doesn't sound like a problem, but this can wreak, havoc inside of the body. If we start talking about knocking electrons off of the atoms that make up DNA, this can lead to mutations. It can lead to cancers, and etc. So, ionizing is a big problem inside of the body, and obviously the higher the ionizing strength, the stronger its ability to knock off electrons. And just to build off from there, really, alpha has a very high ionizing ability. And what that means is that, alpha radiation can quite easily knock off these electrons on atoms. And remember, I said that can cause massive problems inside of our cells, especially for structures like DNA, where if the atoms become ionized, it can lead to all sorts of problems. So that's pretty much it for alpha. Let's take a look at the second type of nuclear radiation that you guys have to know about. And the second type of radiation is called beta. Depending on how you pronounce it, I've been corrected by many people who say it's beta, but I pronounce it beta, tomato. The symbol, though, for beta, you can see it's this B with like a long back. That's the best I can describe it. You can see it's like a capital B, but with a long back. And beta radiation is made up of fast moving electrons. Okay, that's what beta radiation is made up of. Now, beta radiation has a much longer range in air, and what that means is that beta can travel a lot further than an alpha particle. It can typically travel about 1 meter in the air. And again, you are expected to remember these different properties of radiation. Now, beta radiation is typically stopped by a few sheets of aluminium. Okay, beta can penetrate the skin. It can penetrate paper, but it's typically stopped by just a few sheets of aluminium. Its ionizing strength is moderate, so it's nowhere near as ionizing as alpha. I suppose we can say it's in the middle of the three. Beta still has the ability to knock off electrons, but it's not as ionizing as alpha. And then our final type of radiation, and the one that I'll finish on, is gamma. And gamma kind of looks like a Y shape, a capital Y. Gamma's the one that, I don't know if anyone out there watches the Avengers. Gamma is what produced the Hulk. I'm a bit of a Avengers / Marvel geek there, so you can imagine how excited I was when I heard that gamma radiation was involved with the Hulk. That's why I've done it in green as well. But gamma radiation is quite simply an electromagnetic wave. Okay. You'll notice if you've looked at the electromagnetic spectrum, we will probably look at that in future lessons. But gamma is actually a wave in the electromagnetic spectrum. So because gamma is a wave, it's not actually made of any particles as such. It's just this high energy wave. Now, gamma has the biggest range in air out of all of them, because gamma can actually travel a few kilometers. Okay, so a few thousand meters gamma can travel in air. Now, gamma is not actually stopped by any material, but it can be weakened by thick lead or concrete. So we can't typically stop gamma, but we can weaken it using these materials here. And in terms of its ionizing ability, well, gamma is weakly ionizing. It's not very ionizing at all. Obviously, exposed to large doses of it can be a problem. But gamma compared to alpha and beta is very weakly ionizing. I know that there's a question for you guys today where you have to look at which radiation is most dangerous inside the body. But just to give you all a bit more for your money, I also want you to think about why do you think, and I'll finish on this point, just to bring it back to the Simpsons, where Homer Simpson works in these nuclear power plants. What you typically find, I'm just going to rub this out at the top here. What you would typically find is that inside of these nuclear power plants, you have these reactor cores, okay? And inside of the reactor core, you're basically crashing atoms together. But the interesting thing is that the core, this is the core here, but the core is covered in like a concrete shield. See if you guys can look at the 3 different types of radiation and just explain why you think the core is covered in this concrete shield. And I'll hand back over to the guests of the day, sorry, to the presenters of the day.
Thanks, Mike.
No problem.
Yeah, really appreciate it. So what do you have in store for the rest of the day then?
I'm about to go for a run, do some skipping, just keep this quarantine weight down.
Yeah, well, tell me about it. I've got the same thing, skipping ropes. I try and do 50 more each time. That's always the plan for me.
I just watched this YouTube video where a guy does like 15 minutes of skipping broken up in 1 minute slots. So I'm going to go try that right now.
Bit of interval. Sam in our previous session would have been able to tell you exactly what method of training that is and all that sort of stuff.
See, there you go. I should have tuned in.
Yeah, I think it's interval. I can't remember. But Mike, thank you. And obviously you've highlighted the task already for all of us. And again, please make sure you refer back to Mike's work across the portal, across our social media platforms as well. And it's always a pleasure and genuinely always very, very insightful. So thank you, Mike. And thank you, mate. And I believe, Nish, in a couple of moments' time after a short break, we will be having our weekly Spanish session as well.
Yes.
Thank you. Well, I very much look forward to that. I'll see you guys in a minute.
In a bit.